So, hello, I'm Markus. I do data science for business and pleasure. I blatantly just changed the name because someone told me that arcane is a complex word and I should not use it in the title. Well, among other things, something I do is I analyze your service provider's data. I do that so that they could make more money and that they could make more services that make even more money. But that's not really what I care about, because what I care about, why I do this at all, is I care about data science. And sometimes I'm afraid for data science. And why? Well, it's an area where there's a mixture of really high expectations. Everyone has an idea of what machine learning should do. But it's at the same time, it's combined with sometimes bad practices, sometimes shoddy management. And having those two, well, it's a recipe for disappointment. And disappointment is bad for data science and, well, my business as well. I think we can all agree that machine learning is a really fascinating field. It has a lot of potential. And now, I'm not saying this as a visionary that let's haul everything to a black box and machine learning can solve all our problems. I'm not saying that. What I'm saying is that I have seen and experienced how machine learning can make everyone's lives easier by giving us the information we need when we need it, helping us solve our problems when we have the need. And I've had the opportunity to work on a few projects which help reduce the number of people who have to do stupid jobs and also reduce the dullness for those people who still have to do those stupid jobs. So I would really like to remedy the situation. So to do that, I wanted to share my 2 cents about what I've seen in the practices, what I've seen is wrong, and what could be done better. Well, I think we should start with understanding how companies approach machine learning these days anyway. So very broadly speaking, you can separate these people by their approach to machine learning into 2 groups. They are either people who are kind of experts, who know what they're doing, they have an idea where they want to go, they have an idea of the methods and so on. This is very nice. But for most people, the plan looks something like this. And, well, it's not a specifically bad plan. I mean, the core idea is there. You got to get value out of this, right? I mean, if the problem owner doesn't get value out of the project, is it profit, is it social good, whatever, then they're not happy. And if they're not happy, then I can't build cool things. And I would like to build cool things. So our first sort of business is to understand why this happens and not do that, not be that guy. In a way, it's easy to understand. Most businesses these days generate huge amounts of data. Is it logs, or is it images, video feed, audio? Everyone has some kind of data and immense amounts of it. It's cheap to collect, cheap to store. So now imagine you're sitting on this data and you'd like to do something with it. Yeah. So the first question that comes to mind for a lot of people is, we have tons of data. Could we do something interesting with it? Every time I hear this kind of problem statement for a customer, I groan internally, and I smile outwardly, and I explain. So this is something that I call a data-first approach, and it's actually really simple to understand why this happens at all. It's the business people, the data is something they know. This is something they have in hand, and they know how it's generated, they know where it comes from, and deep in their bones, they have this feeling that if I just looked hard enough, I could answer most of my questions from the data that I have here. And because it's so complicated to look at this big data using, not big data, but just big data, look at it with tables and Excel and SQL and things like that, then it feels so enticing to just hand it off to a black box and get magic and business ideas and money out of it. But this is not actually what happens. When you do this, then most of the time what really happens is that you give the data to a bunch of enthusiastic data scientists who start digging around it for patterns. And after doing it for quite a long time, They will find some interesting patterns, something kind of relevant to your business, but most of the time it's not optimal. And why is because they're data scientists. They are probably asking the wrong questions or just questions that are not relevant to your business. So if you add to that the costs of like implementing this, both on infrastructure-wise, technically, and also implementing this in the workflow, the costs are going to be so high that it's not going to pay off. And this company is going to think that data science is just like all hype and nothing interesting is ever going to happen again. So because I really don't like that, and I see that happening quite often, even today, I first talked about this, I think, about a year ago, I would like to propose something like a bit better. I call it a problem-first approach. And because I've been a huge nerd my whole life, and I come from natural sciences, then I've had the scientific process close to my heart. And this is something that we could maybe use here. I mean, scientists all around the world have to get really good results while using almost no money because they're underfunded everywhere. So maybe they're onto something. The scientific process itself is fairly simple. It's a 5-step process. When you simplify it, but still, it's you formulate the question, you formulate the hypothesis to test, you test them, and you analyze them. But how do we fit this to machine learning projects? Well, if we think about the question here, the question should probably be the business problems that solving of which generates a lot of value. Obviously, someone who knows the business has to come up with those. These problems, they have to be like thought out by the business people, but at the same time they have to be machine learning solvable. Then you have to, in the process, have the two sides at the table. So start with the business people. Find the guys who lead the sectors in your business, who know the problems, and ask them to define a number of problems in the area. This can be something like discovering churn, the reasons of churn. This is very popular. Another good one is how to make more sales with less calls. It's becoming more and more common. So after you've generated this bunch of questions, this is where you get your data people on board. Because with the data people, you're going to first assign potential value to each of these things, and then potential costs and potential issues to there, and you're going to have a list of problems, and ordered by potential value and how you would like to execute on them. So things you would like to have to keep in mind are value, how much will solving it generate for you, and the difficulty of how complex is this project? Is it going to take a month, or is it going to take a few years? In machine learning, it's also the probability, it comes to play. It might be that the solution is probably there, but it totally might not be as well. And the third question, which might be the most important at times, is should I do it at all? Should I use machine learning to it? I was recently approached by a person who was selling financial services. And what he wanted was, he felt that he has to scrape some data off some web pages and find the exact spots, and it's a tedious task, and he wanted to automate it. So we sat down and had a lunch and talked about how we could solve this thing. Quite quickly, it turned out that it's actually a task that a human would have to spend a few hours a month on. Well, it wouldn't be a difficult machine learning project either, but if you consider the hourly rate would have to be insane for the machine learning project to pay off. So really think about that. You can throw a lot of the projects out of this list simply by asking that. So now you have this list. It's a good place to make a pause in the scientific process and strategize a bit. What I mean here is that the list you have is really good, but you should think about it a bit more thoroughly, because a lot of these things have common preliminaries, or they connect to each other. Say that, for example, to give users better information faster, you have to develop a summarization technique, something that reads the text and summarizes it quickly. Well, you can use the same technology for internal knowledge base that you have. So knowing that they two share the same preliminary actually makes both of the projects a bit cheaper. It might also be that the output of one project leads to leads in as an input to another project. For example, say that you're building an NBO system. NBO is next best offer. To anyone who doesn't know, it basically means that if you want to sell someone something, then what's the best thing to sell them? Well, obviously, if you build a happiness index, it's going to tie into that. If you have a customer lifetime value model, this is going to tie into that. NBO itself is going to tie into churn prediction model, should you have that. And these also interact with each other in some ways. So all these interactions generate some extra value for each of these projects. So when you start listing them and start thinking about which to execute first, this extra value is something you could keep in mind. This strategizing little task, it's a really good starting position it's a really good, actually, it could be a backbone of your AI implementation strategy. But if you don't want that strategy, it's still a good task to do to like exercise your mind and know where to start with the project. So if that's done, we can move on to setting the hypotheses. This is so you have the list of problems, and now you have to find out what are the avenues of investigation you should pursue. Machine learning usually finds a lot of hidden patterns in the data. It finds connections that we wouldn't see because it can look at things on a larger scale or look at everything very, very thoroughly or look at larger time frames. Doesn't really matter why. It finds connections we don't. But still, it's a really good idea to start with domain experts' knowledge. So for that step, you need the boots on the ground, the people who actually deal with the problems every day, be it customer communication or, I don't know, lifting things on a factory floor. You need to speak with those people. They know the ins and outs of the problem. They know what the easy parts, the hard parts, the parts that go out of the normal procedure, and know why the current system doesn't really work at some points. Ideally, you'll map the whole process, what they do, and with all the complex parts they have to deal with, every problem they see, so on. This has immense value. If you don't do this, if you don't talk with those people, if you don't have them on board, then you're gonna waste a lot of time stuck in the reads, just looking for, I don't know, letting a machine find the patterns automatically. It's just gonna take a bit longer. So you got that set out. Now you can move on to the real work, and testing. Testing the hypothesis is, this is the data guy's problem. This is where your data guys come in and they start exploring the data, engineering the features, building the models and so on. And invariably, they're going to come up with ideas about the data. It's either discrepancies with the procedure that was given to them, they see that the data doesn't fit, or maybe they have some ideas about like what could work as well, should they try. And a lot of these hypotheses are good, but they have to be run against the business people and the boots on the ground, the people who know the process. This is a lot of communication. And to facilitate that and to remove a lot of the friction, there's another person you need in this stage. It's someone between business and science. Someone who knows both worlds and who can communicate between those two. This person is like vital if you want to reduce the friction, because this guy or girl ideally knows what the data scientists are asking and also knows what the business side needs. So most companies don't have that kind of person. If you do, go find him. If you don't, you have to train them. Training this person takes quite a while, but if you choose wisely, well, finding a person these days who is interested in machine learning is actually not that difficult, like kind of everyone is. So finding that person is not difficult, and if you choose them well, then and give them free rein, then actually they make a lot of the training work for you. They can learn on their own. And what I should also say is that the testing step is a really long one. Like it can go on indefinitely if you don't stop it. So you have to set a timeline. But machine learning being probabilistic as it is, the timeline is going to be a bit more hazy than a lot of people are comfortable with. It just, you don't know how long some projects take at times. But as long as you stay within reason, it's going to work out fine. Now if that's done, you go to the analysis step. You find out what are the good ideas, what are the bad ideas, what works, what doesn't. Separate the wheat from the chaff and gather all the knowledge. Like why didn't some hypotheses work out? What's wrong with the data? Should we try something else? This is the part where you distill everything you got from the testing phase. When you've done that, you go to the Step number 3, start setting hypotheses again, start testing again, and you rinse and repeat until you found the solution to your problem. So there you go. You can manage now data science as you do any other science, all the while not worrying about the grant. Now I hope that you noticed. It's really hard to not notice it because I talk about it all the time. But, in this method, the people are at least as important as the method itself, the kind of people you have. You have to have the right people on board at each step. If you don't, you're just gonna waste everyone's time. Like at best, you're gonna waste time. At worst, you're gonna ruin the whole project. Nothing's gonna come out of it. In my experience, that's also the hardest part: finding the right people, getting them on board, and getting them interested. Because people do investigative work a lot better when they are actually interested in the problem. Now, of course, I deal with it from an agency side, which means that access to the people is less more difficult, so your mileage may vary with this one. And in the end, I'd also like to stress that this is not a magic method. It's not going to solve everything. It still requires a lot of work. It requires a lot of investment. But if you do it right, I think it will be more than just worth it. So go on to the world and go do some great data science projects. Thank you.
Thank you. Do we have any questions for Markus here? We have over here. Just bringing you a mic, so one moment there. You can stay there, it's okay.
Cheers. Thank you, Markus. Very interesting talk, as always. I have a question. You mentioned that in order to succeed the project, you need somebody in between business and data science guys. And you also mentioned that if you don't have that guy, you should train them. What do you think, in your opinion? Is it better to train a data science guys to be more business-oriented or the other way around?
In my experience, it depends, of course, like how large is the company and how complex the systems are. But I do believe that it's easier to take someone on the business side and teach them machine learning. Because like, in generally, knowing machine learning so well that you can practice it, it takes a long time. But if you only have to know it good enough to understand the process, understand what the people are doing and give them good input, that takes a lot less time. And being acquainted with the business itself, I believe that takes a really long time. You'd have to live in the company.
Okay, good answer. Anybody else there for Markus? All right, gone. Oh, no. You wait to the last minute. I'm halfway through my speech.
Just going back on the hypothesis formulation part and what you can do with data. With data, evidently you can find connection, as you mentioned, and it could be just correlation. Are there any statistical ways to actually move beyond correlation and perhaps find causation links, if possible?
I do believe that if you want to find causal relationships, then the only way you can do that is by experiments. Finding causal relationship from static data is a complex and shady business. I wouldn't go there.
Okay. All right, very good. All right, please, one more round of applause, Markus. Thank you, sir.